Let's talk about normal distribution with standard deviation. First of all, the normal distribution is a type of continuous probability distribution, and it is often used to model natural phenomena in different physical, social, and behavioral sciences. So you may know this as a bell-shaped curve or a bell curve. So I'm going to go ahead and I'm going to draw this bell curve on my screen. And you're going to notice that when I put this on an axis, it's not going to be right on the axis because there is a horizontal asymptote, okay? The horizontal axis is an asymptote of the curve. And as a reminder, an asymptote is a line that the graph approaches but never crosses or touches. Other properties of the normal distribution is that it is symmetrical about the mean. So right here in the center, we are going to have the mean, and mu is going to be the symbol that we're going to use for the mean. And in this normal distribution, notice that the maximum height of the curve occurs at the mean. Other properties that you need to be aware of is that the mean, the median, and the mode are all exactly the same value. And like we said, the normal distribution is basically a bell-shaped curve. The total area under the curve is 100% or 1. And so notice that because the mean cuts it in half, that means that the area to the right of the mean accounts for 50% and to the left also accounts for 50% of the distribution. The notation that we are going to use for a normal distribution is that we're going to say capital X, which basically just denotes any event, is normally distributed with a mean. Okay, so the first number represents the mean, and then we have sigma squared, and that basically represents standard deviation. And be careful with the square. Sometimes my students get confused with the square, but you have to think of that as what I call kind of like decoration. It's not really there. So if they give you an example where they tell you the x is normally distributed and you have the mean is 15 with a standard deviation of 5 squared, that's exactly what it means. The average is 15 and the standard deviation is 5, okay? So you don't square the 5 and make it 25. The standard deviation is 5. So what we're doing basically on this normal curve is that we're talking about the spread in terms of standard deviation. So we're going to go out 1 standard deviation on the right. We're going to go 2 standard deviations, 3 standard deviations. And I'm going to do exactly the same thing on the left, where I'm going to move 1 standard deviation to the left, minus 2 standard deviations, and then minus 3 standard deviations. So then what we're going to talk about right now really quickly is what's called the empirical rule. The empirical rule is basically a statistical rule of thumb that applies to data that is approximately normally distributed. This rule provides a quick way to estimate the proportion of data that falls within a certain number of standard deviations from the mean of the distribution. So it is also known as the 68, 95, 99.7 rule, because what this tells me is that as a rule of thumb, 68% of the data falls within 1 standard deviation of the mean, okay? So here's 1 standard deviation of the mean. I'm going to go ahead and shade this in purple. So this represents about 68% of the data. So that's the first part of the empirical rule. The second part is 95%. Basically what that means is 95% of the distribution is going to be within 2 standard deviations. So already here, notice this covers 95% of the distribution. And basically 99.7% of the values will lie within 3 standard deviations of the mean. So right here, if I shade all of this up to 3 standard deviations from the mean in, you're going to see that this represents 99.7% of the entire distribution, which is why most of the time when you see these bell-shaped curves graphed, you're going to see that you only go out to 3 standard deviations on either side of the mean, and that is because that already represents 99.7% of the distribution. So let's go ahead and take a look at this example. It says if x is normally distributed, remember the mean in this case is going to be 41.1 and the standard deviation is 13.5. Find the probability that x is greater than or equal to 23. Okay, so what I'm going to do is that I'm going to draw a bell-shaped curve so that I can basically get a visual as to what this looks like. Down here in the center, I'm going to put the mean, which is 41.1. I can go ahead and grab the calculator if you need it and add 13.5 to the 41.1. And that gives me 54.6. If I do this again 2 more times, I'm going to get 68.1 and 81.6. If I want to figure out what these are for the left side, all I have to do is take 41.1 and subtract 13.5, and that gives me 27.6, 14.1, and 0.6. So that already covers 99.7% of the distribution. Now the problem in this case is to find the probability that x is greater than or equal to 33. So 33 is going to be somewhere around here. It's more than 27.6, less than 41.1. And because I want the probability of x being greater than or equal to 33, I want the probability of everything that's to the right. So I'm going to shade everything to the right. Now, why do I do this? Number one, a visual is going to help me to determine what is happening in the problem. I can very clearly tell that my answer that I expect to get is going to be more than 0.5 because I have shaded more than half of my distribution right now, half of my curve. So what do I do now? I have to go to the calculator. I'm going to go to second vars, which is where you have to go to find your distributions. You are going to find normal CDF, because you want to find the cumulative density function. Hopefully your calculator is going to prompt you to enter the lower, upper, those are your bounds, the mean, and the standard deviation. So in this case, the lower bound is 33 because I want to find the probability of 33 or more. The upper bound is positive infinity, which I'm going to enter as 1E99, and this E is not the letter E. It's not like an E for elephant, okay? It's like exponential notation. So here, the way you find that E in the TI-84 calculator is second comma. And then my mean, if you remember, is 41.1 in this problem. And the standard deviation is 13.5. So I'm going to go over to the calculator and show you how to enter this. So we're going to go second vars. You're going to go to normal CDF. The lower bound is going to be 33. My upper bound is 1. Remember, second comma for exponential 99. That means positive infinity. The mean here is going to be 41.1 and the standard deviation is 13.5. I'm going to press paste and then I'm going to press enter. And so the answer is 0.726 if I round it to 3 significant figures. So my answer is approximately 0.726 if I round this to 3 significant figures, which is about 72.6%. And it makes sense because I knew my answer had to be more than half. Okay, so let's head on over to a new example. In this example, it says, if x is normally distributed, remember the mean is 40, the standard deviation is going to be 1.7. Find the probability that x is less than or equal to 38. Okay, I'm going to go ahead and draw a diagram. I'm going to draw my bell-shaped curve. Right in the middle, I'm going to put the mean. In this case, the mean is 40. Now, I could go plus 1.7, plus 1.7, so that I get a better picture of exactly what's happening here. Or I can just kind of use an approximation. So if I go here, I know that's going to be 41.7, etc. And if I go backwards, and if I do 40 minus 1.7, then one standard deviation out, I'm going to be at 38.3. So I want the probability that x is less than or equal to 38. So I'm going to be to the left of 38.3 by a little bit. And because it's less than, I'm going to shade everything that is to the left. Notice I expect my answer for sure to be less than half. And if you remember the empirical rule, it says that 68% of the data falls within 1 standard deviation. If I divide that by 2, that means that just this left part alone is going to be 34%. And so 50 minus 34% is going to give me 16%. So I expect already my answer to be approximately 16%, or roughly about 0.16. Let's see how close we are to that answer. So in our calculator, we're going to go again to second vars, option 2, which is normal CDF. We have to enter our lower, our upper, our mean, and our standard deviation. For those of you who are not prompted, maybe you're using an older model calculator, and when you go to second vars, normal CDF, you're not prompted lower, upper, mean, standard deviation. What you're going to have to do is enter those numbers in that order, separated by commas, and you're going to be able to get the answer. So in this case, your lower bound is going to be negative infinity, so -1 E99. Remember, negative is not subtraction, so use the negative button. Also, E, in case you've already forgotten, is second comma. Okay, that's how you enter exponential notation. To the 99th power, which basically means negative infinity. The upper bound is going to be 38. The mean is 40, and the standard deviation is 1.7. So in the calculator, second vars, option 2, normal CDF, the lower bound is negative infinity, so -1 E, which is second comma, 99. We wanted to go as far as the upper bound, which is 38, because I want to find the probability that x is less than 38, less than or equal to. And then the mean in this case was 40, and the standard deviation is 1.7. Now I'm going to put paste. Before I go ahead and reveal the answer, remember that just by using the empirical rule, we are already anticipating the answer is going to be close to 0.16. And notice our answer is 0.1197, so it's about 0.12. And that is basically pretty close to about that 16%. So definitely the empirical rule was able to help us to find a good estimate of our answer. So this answer is about 0.1197 ... which means it's approximately equal to 0.120. And so therefore that means that that area under that curve that I shaded in red is about 12%, or 0.12. Okay, so let's head on over to this last example. If x is normally distributed, and notice that the mean is 0 and the standard deviation is 1. By the way, this is called a standard normal distribution. And I don't think it's something necessarily you have to memorize depending on the math that you're taking, but it is something for you to be aware of in case you ever hear them talk about standard normal distribution. It's basically just a distribution where you have the mean of 0 and the standard deviation of 1. So I'm going to go ahead just like before, and I'm going to draw a quick diagram to illustrate what is happening in this problem. It's going to be very simple because the mean is 0 and the standard deviation is 1. So I'm going to go out +1 and then -1, 1, 2, 3, -1, -2, -3. In this case, I want the probability that x lies between -1.5 and 0.7. So basically, this is what I want. I'm going to shade this area in. I'm going to go to my calculator. I'm still going to go to second vars, option 2, which is going to be normal CDF. My lower limit in this case is going to be -1.5. My upper limit is going to be 0.7. The mean is 0 and the standard deviation is 1. So in the calculator, I go second vars, option 2, normal CDF, and I'm going to be entering my lower bound as -1.5, my upper bound as +0.7. My mean is 0, my standard deviation is 1 because this is the standard normal distribution. I press paste and enter, and my answer is 0.691 approximately. So that means that the probability that x lies between -1.5 and 0.7 is going to be approximately 0.691. Hope you found this video helpful. Remember to subscribe to my channel for more help with math so that you can say, yes, I can do math with confidence. Until next time, thanks for watching.